Welcome to our Marlow Solar Streets presentation. I'm John Laker, Director of Marlow Energy Group, and we're conducting a short slideshow just to get us into the main.
No, right. Well, I'll move.
Can I ask people to mute, please? Otherwise, we'll hear everyone's conversations. Right. Introduction to Marlow Energy Group. As you can see there, it's a not-for-profit community benefit society, registered as such. We have 4 main objectives. I'm not going to read them. Please read them as we go along. Give you 30 seconds to go through those. You can see they're hopefully extremely good objectives. Our next event, as far as we're concerned, is our 6th Ask the Experts event, which is on a hydrogen-powered car, explained. It's on the 9th of February, as you can see. If you want an invite, just go to the Marlow Energy Group website and you will find out more information there. We need volunteers to achieve our objectives, and we need money as well. If you have a spare £10, please join MEG, Marlow Energy Group, and or make a donation. Every little bit helps, and you can join again on the website www.marlowenergygroup.com. Right, I think before I go on to that, I just have one quick statement to make so that you are aware before we go into this, and I'll read it out. Marlow Energy Group initially approached 6 different photovoltaic PV solar panel companies in our attempt to increase the number of PV solar panels in Marlow. Currently, around 80 houses in Marlow have PV panels, which is about 1%. And we were intending to decrease CO2 emissions into the bargain. We chose IDDEA to give the presentation as we think they probably offer the best value for money, have proved they can market the scheme well and provide a community benefit which MEG will manage. However, as a CBS, we must be impartial, so if you do consider purchasing PV panels in future, we do advise that you seek comparative quotes. So the next slide is introducing Andy Tunstall, Director of Green Group. Off we go.
Yeah, okay, thanks. So thanks for that introduction, John. I'll just see if I can share my screen as well. Hopefully I'll be able to get it to fill the screen. Is that sharing? Not yet, I don't think, is it? Hang on. It's this one here. Can everybody see that?
Yeah.
No.
Hang on, it should be coming up.
Yes, it's
Yes,
visible,
yes, I can see it.
It's coming up. Yeah, that's great. Okay, thanks very much. How we're going to do this is I'll lead the presentation, but as I go through, and it'll probably be quicker if I just blast through the presentation, take about 15 minutes, so that will give us plenty of time for questions and answers. But if you've got any questions that you'd like to ask as we go through, if you use the chat facility, which is at the bottom of your screen, and type in the questions there, Kat, who I mentioned is my partner in the business, will either answer the question directly or make sure that we answer them when we get past there as well. And in the same way that John wanted to ask a preliminary question, we'd also be very interested in how you got to hear about this event, whether it was via MEG, whether it was via Facebook, but whether it was by the Marlovian or some of the Facebook advertising we've done, because that helps us hone our marketing for the future. So if you do have a moment during this presentation to say where you heard about this event, it'd be great if you could put that into the chat box, and we'll look at that after. So this is a presentation that explains how solar streets work, and you can see that there's three players in this. First of all, there is IDEA Renewable Energy Systems, who are the people who basically invented this concept. You've got your local council and or the Green Group. So in this case, it's Marlow Energy Group with support from Marlow Town Council. And also ourselves as the Green Group, and we are part of the Solar Streets makeup, as I will explain. So what this presentation will basically cover is, well, what is Solar Streets? Hopefully you've heard of it, but you might not know what it's all about. So let's first of all outline the concept of what it's trying to do and who's behind it, which is mainly IDEA, spelled I-D-D-E-A, but we always refer to it as IDEA. Then we'll talk a little bit about solar panels as a concept, both in terms of the systems and how they work, but also the economics, because a lot of people don't understand how the economics of solar panels work, and I'll try and explain that to you so you can know what to look out for. And then finally, if you're interested in getting a quotation as part of the Solar Street scheme, how you can make that happen. So hopefully that will work for everybody. So first of all, what are the elements of the Solar Streets offer? Well, first of all, it's an attractive price point. And the headline numbers that we've got are a 12 black panel system, so it's just the plain black panels rather than the silver surrounded panels, is a 4 kilowatt system for a price of £4,000. And we'll explain some comparative quotes at the moment. That represents a substantial discount, probably in excess of 20%, over what you would get if you tried to go out and source your own solar PV panel installation individually for your own house. Secondly, it's very much designed for your house and your needs, and also any quotation will explain what the optional extras you could have on that system to maximise the effectiveness of it. The third element is solar systems, because they are displacing grid supplied electricity, save carbon emissions. So they are brilliant for towns that are looking to minimise their carbon emissions and particularly get back to a zero carbon position by declaring a climate emergency. That zero carbon target means that they're going to get back to the carbon levels that they were emitting in 1990. So most towns that have declared a carbon emergency are trying to achieve that by 2030. And the final element of the scheme is that for every residential installation, there's a £50 donation that goes into a community fund. And if it's a business that's having solar panels, that goes up to a minimum of £100. And all of those numbers are added together, and they are managed by effectively the sponsor organisation, which in this case is Marlow Energy Group. So they will decide what sustainability projects all those donations would be spent on. So let's talk about some of those elements in a bit more detail. So first of all, that price point of £4,000 for a 4 kilowatt system. So we've done a bit of research, and the Energy Savings Trust, and you can see the web link there, reckon that the average size system in the UK is a bit smaller than that. It's 3.5 kilowatts capacity, and the average price at the end of, I think it's the end of 2019, was £4,800, including VAT. So that's £800 more for a smaller system. And the second reference point is there's quite a large solar company in Reading called Spirit Energy, and you can go onto their website as well. The same size system as we are tying the price point to, a 4 kilowatt system, they say the average price is £5,500, including that. So you can see there that certainly versus Spirit's estimate, a Solar Streets price saves about £1,500. So that's coming on for, you know, just over 20%, I would have thought. So that's the first point. It's a very cost-effective way of getting a solar system installed. So let's tell you a little bit about IDEA. So they are a renewable energy installer who's been going since 2008, and in the renewable energy industry, that's quite a long time. Which means that they've gone through the roller coaster of the various different feed-in tariff rates that have been available, and the vastly different price of solar panels that's gone on. If you were to buy that 4 kilowatt system in 2008, it would have cost you £18,000, but you'd got a very generous feed-in rate with it as well. They are specialists in providing solar PV, battery storage systems, which can be linked to it, and electric vehicle charging points. They've installed over 1,000 systems, right from small domestics to on commercial buildings and schools, and utility size solar farms that you sometimes drive past. They're committed to taking control of energy bills and fighting climate change. And the expansion of solar streets meant that they opened up their second branch in High Wycombe, just up the road from you, in October 2020, from their original head office branch, which is in the West Country in Westbury in Wiltshire. And myself and Kat's company, the Green Group UK, we effectively are the sales and marketing part of the Solar Streets project, and we do some commercial work with IDEA as well. And we are the people who link with the councils and the various different green groups, and also do all of the marketing to try and attract people to events like this. So if you're looking at a solar PV company, and John quite rightly said that, you should seek more than one quote when you're looking at doing this, because it's a substantial investment. You should always make sure that the solar company you're dealing with has got all of the right accreditations that you need. And three of the crucial ones are the MCS, which is the Micro Generation Certification Scheme, just about remembered it. And this is absolutely essential if you are going to try and claim some of the smart export guarantee that I'll explain later on. HIES is how it is pronounced, HIES, is a way of protecting your deposit in the unlikely event that the company who is supplying your system goes bust after they've taken your money. So your deposit that you pay for your system is protected, and you would always get your money back. NAPIT is a body that certifies that a credible company has got all the various different insurances they need. And not mentioned on there, we should add this on, I guess, is that being electricians, IDEA are able to self-certify all of their work under all the electrical regulations as well. So basically, IDEA are a credible company with all of the qualifications they need to do a proper solar PV installation. So one of the key questions you'll sort of say is, well, you're saying your offer is £4,000 and, arrival offer might be £5,500. Well, how can you do it so cheap? Well, the reason for that is economies of scale. So what we do is we focus on a town or a small area at one time, and we try and get 10 people to commit to buying a solar PV system in a relatively short period of time. We work with the councils and the local action groups to raise awareness and therefore benefit in terms of marketing. And the ability to deliver in blocks of 10 means that we can get a better rate on the panels themselves and other items such as the inverter, which is one of the crucial parts of the system. So basically, getting people together gives us economies in marketing, in surveying, in installation and scaffolding. So all of those things give us an ability to get the price very competitive. So solar streets so far, you can see down the left hand side there's a lot of towns that we've been doing this in since we started it in April 2019. You can see there that the first three were in the West Country, and that was because that's where IDEA started. But then we move into West Berkshire, Henley upon Thames, which is the first one where we got involved with it, St Albans, Thame, not too far from you. Another one, Bruton and Castle Carey down in Somerset, Marlow, yourselves, Haddenham, we have a Zoom call on Thursday, very next to Thame, of course, and then Brew Valley and Somerton, again in the West Country, and probably another 3 or 4 that are going to come in over the next few months, and many more in the pipeline as well. So a lot of excitement about this project overall, and we've had something like 300 inquiries since April 2019. We've done over 200 surveys, and we've installed over 100 solar PV systems under the Solar Streets banner. And therefore, we've saved over 101 tonnes of carbon. And of course, because we do £50 per installation, we've also generated about £5,000 in community fund donations, which have gone to those various towns on the left-hand side as well. Here you can see some of the installations. Now, one of the interesting things for me is if you look at the top ones, these were the earliest ones that were done in 2019. And you can see there that they are silver framed solar panels, whereas the ones down the bottom, which have been installed end of 2020 are now a black panel design, and these are the ones that we are standardizing on now because they're less obtrusive. The other difference between the panels in the top part of the picture and the ones down in the bottom is that the top ones were 275 watts per panel and the bottom ones are 340 watts per panel. Now that means that you can get a higher output from a smaller roof area, which means that now using higher powered panels we can make a viable system work on even a relatively small roof. I mentioned about the community benefit. The first town where this was launched at, and very, very successfully, is a town called Frome in Somerset. It's a very very bohemian town, lots of craft shops and everything like that, but they've got a real big community spirit going on there. And what they did was they have 7,000 owner-occupied houses, and 70 installations were installed within a year, which equates to 1% of owner-occupiers, which is a number you'll hear me refer to again. So 70 installations times £50, that adds up to £3,500. And what that did was paid for actually quite a large installation at the town's YMCA Youth Club, and you can see it on the top of the picture there, just behind the scaffolding. It's just being put in at the moment, and here are some of the people of Frome who are going to benefit from that. So what that means is that the club is going to save carbon, but also crucially it's going to reduce its electricity bills, which means it can invest more money in providing more classes and other activities for people within the town. And that's just one example. Some other towns have done smaller grants to the fuel poor and various other schemes, and we agree with the local sponsoring group what that money, that donation can be spent on, and as long as it's sustainable, we're happy to support whatever project is popular with the locality. Right, now here is an example of a small, well, an installation in it's Wargrave, actually. It's near Henley upon Thames. So see how this goes. Oh. This has happened, but this has worked before, so let's hope it goes again. Come on. Here we go.
It's the gaps underneath, obviously, where the pigeons can go.
I presume that's where we're going.
Okay. Come on, next slide, next slide. Right, there we go. Go on a little bit further about the concept of solar PV and what it is. Basically, the PV stands for photovoltaic, and basically the sun's rays shine onto the panels, which convert that energy into electricity, into direct current DC electricity. It goes through to an inverter, which converts it to useful AC electricity. And then that AC electricity is either used in the house or it's exported back to the grid. Now, when you've got a solar system, you can be very smart in your use of that system and save yourself more money. So you can do things like use excess solar to heat your water instead of using your gas boiler by using a simple device called an iBoost, which is one of the optional extras. You can schedule your use of energy intensive appliances such as tumble dryers and dishwashers at times when your solar panels are producing. So that would mean that you'd be using those appliances during the day rather than at night. It also makes you very conscious when you want to try and use the maximum amount of your solar output on when you do other things like you use your kettles, you charge mobile phones and laptops, etc., etc. And there's little things like you can do, like using a slow cooker, which we've rediscovered from student days, which use the power of a light bulb through the day and produce some very nice tasting stuff as well. And you could also use battery storage systems as well, which we can tell you about. But the key thing you're doing is when you're using electricity from your solar panels, you are displacing the grid supplied electricity, which costs you 15p per kilowatt hour. Now, there's no feed-in tariff anymore, as I mentioned, but what there is since January 2020, all energy companies who supply your electricity, who've got more than 150,000 customers, are obliged to offer you a smart export guarantee. Now, that is a tariff, which means that if you don't use your solar electricity, then they can effectively pay you a credit for the units that you export to them. Now, the government very generously said that that tariff had to be greater than zero. And the tariff ranges are between 0 and about 5.6p per unit. And an example of a company we work with, Octopus Energy, their smart export guarantee tariff is 5.5 pence per kilowatt hour. So the important thing to notice there, if we compare that to the previous slide, you're saving grid supplied electricity at 15p, but if you can't use it, you're exporting it at 5.5p, which is obviously a lot less. So when you're choosing your supplier, you should be looking for two things. One, how much they're going to charge you for your electricity supply, and two, how much they're going to give you for your solar export guarantee tariff for your exported energy. I mentioned battery systems. Battery systems are quite useful for solar systems because solar systems obviously generate electricity when there is daylight, not necessarily when the sun's shining, but when there is daylight. So what a battery can do is, imagine if you're the sort of person who is not at home much during the day, the battery system can store all of that solar electricity your solar panels have produced. And then when you come home in the evening, perhaps when the light is fading, you can then use the electricity that's been produced by your solar panels. And that's a way of making sure that you get that crucial percentage of the output of your panels, a higher proportion using yourself. Now, we'll talk about some of the stuff we've got on some of our other web pages, but a very, very simple calculation on how you would assess the benefit of a solar system is this. So a typical capacity system, a 4 kilowatt capacity system that we talked about that cost you £4,000 in the south of England is likely to produce 3,600 kilowatts per year, which will suit a 3 to 4 bedroom house. But the only trouble is it's producing that at times when you might not be able to use it. So a good objective might be to say, I want to try and use half of that electricity that's been produced, i.e. 1,800 kilowatt hours myself. So that 1,800 kilowatt hours would save you 15p versus importing it from the grid, i.e. £270. But the other 1,800 kilowatt hours produced by the solar system would be exported. And if we assume that the smart export guarantee rate was 5 pence, then that would save you £90 as a credit on your electricity bill. So therefore, you've got £360 total savings based on your investment of £4,000. But there's another thing going on here, is that electricity prices have been going up over the last few years at double the rate of standard inflation. So this saving is likely to get bigger over time. So that 360 might be, I don't know, 390 the following year and so on. So it would mean that your savings are likely to grow from your solar system over a period of time. But the biggest single impact will be how much of that own use you can use. The more you can use, the more you will save, and the lower the payback period of your panels will be. And even if you did a rough calculation and you assumed that that 360 was say 400 on average, and this system will get a payback in 10 years, the solar system will last for 25 years. So once you've spent 10 years paying for it back, you get 15 years worth of free electricity, and you've saved 1 ton of carbon every year throughout its life as well. One of the questions we get asked a lot is about planning permission, and do you need planning permission to put up solar panels? In most cases you do not. However, the exceptions are where if you are in a conservation area. Now, if your roof face is not facing the road, you should still be okay. But if your panels do face the road, then you do have to ask for permission. But it may be the case that your authority will still grant permission. We know, for example, in Reading, that solar panels have been allowed even in conservation areas. And there's a couple of other little criteria there. The solar panels are not allowed to exceed the total height of the roof, and they're not allowed to project more than 200 millimeters. And listed buildings are a particular problem. And at the moment, it is mostly the case that if you have a listed building, you won't be able to put solar panels on your roof. And even if you have a more modern building in the grounds of that listed building, it's unlikely you get planning permission to put panels on that as well. So that is a consideration, and it's one we get asked quite a lot. But this doesn't apply to a lot of people, but it does apply to some. What's the potential benefit in Marlow? So these are quite old figures. These are 2011 census, and I'm sure Marlow's probably got a little bit bigger from them, but these are consistent numbers we've been using. So there are just over 8,000 homes in all of Marlow, including Marlow Bottom. Nearly 6,000 of those are owner occupied. So if we can achieve the same sort of percentage install rate that was done in Frome, then we'd expect to get about 60 solar installations in the town, which would drive a community benefit of £3,000, but more importantly, in some ways, it would save 60 tonnes of CO2 for the town per year. So if all of that's of interest, then basically here's the next stages in the process. So what you should do is email that address there, which is info@idea.co.uk, with your full address and your contact number. What they'll then do is they'll have a look at your property on Google Earth, and what that will do is basically highlight any impossible installations. So that means that either your roof space is too small, you've got too much shading, or the direction of your roof isn't ideal. From an orientation point of view, most directions will work apart from north. So if your roof or one of your roofs is facing anywhere between east through south to west, you should still be able to get a viable system. So on the assumption that that part goes well, then you can go on to the next stage, which under the COVID-19 protocols is a technical survey which leads to a quotation. Now that will involve further examination of your roof, but may involve you being asked to take some photographs of some specific parts of your building, usually the roof space, and your electrical connections around your meter. In previous COVID times, that would have been done by a surveyor coming and visit, but at the moment, what we're suggesting is that this is done effectively digitally, and then that will produce a quotation, which you can then decide whether you like the look of or not. If you do decide you want to go ahead, then a deposit will be taken, which is 25% of the job, and then the installation will be booked. Question now comes up about, well, what if we're not, you haven't got 10 deposits yet? Well, I think the view is that we would wait until we've got a reasonable number of deposits and then take those all at the same time. But we think there is fantastic potential in Marlow to get more than 10, otherwise we wouldn't be talking to Marlow Energy Group about it. So we think this will take place. So as long as we're getting good traffic in terms of leads coming through, then installations will be booked and the prices will be honoured for that good price that we've done there. And then just as a final point, further information about this thing. So if you go to solarstreets.co.uk/Marlow. I nearly said Tame then, but no, Marlow. What you'll find there is full description of the scheme and the local sponsors, particularly some words from Marlow Energy Group and a little bit from the local council as well. It will tell you when the Q&A sessions are. We'll do more than this one, but this is the first one. There are some videos on there, which quite an interesting one, and I should say this because I wrote it and star it and perform it, is about the economics of solar panels, a bit like that example that I gave you, but using some various different scenarios and showing how that payback can change. That's proved quite a popular one. As I mentioned, we've got an optional energy deal, and this is for anybody who wants to switch their energy. We asked loads of people if they wanted to do, loads of energy companies if they wanted to support the Solar Street scheme, and one did, and that was called Octopus Energy. So we have a Solar Streets deal with those, but I believe Marlow Energy Group have also got a deal with them as well. So I think either way, there is a way of the town benefiting by that as well. And if you've got any questions, then obviously you've got the chance to offer them now, but the best email addresses to get us on is info@solarstreets.co.uk. So at that moment, I will stop talking and stop sharing and allow the conversations to go. And perhaps we could start by some of the questions which Kat maybe could be able to summarise from the lots of questions that I've can see on the chat boxes there, and I'll try my best to answer them.
Right. I'm going to
Could you just take a question of Hugh has just asked, how much does it cost to fit a battery as well?
Yes, the most popular batteries fitted up is a 5 kilowatt battery, and that's just about £3,000. So that would take your installation from around £4,000 up to £7,000. But what it would do is give you the ability to use a higher percentage of your solar system's output than you would without the battery.
Do you need to put the batteries in at the beginning, or can you add them later?
You can add them later. There's a weird thing about VAT, which means that it's slightly more expensive to put the batteries in as a retrofit, but you could put the system in, say that you're thinking of having the batteries put in later, and make sure it's configured so you could retrofit them at a later stage. So yes.
Andy, Phil's just asked, why does the water heating option work, and why is it different from just switching the immersion on? So if you want to just talk about heating that during the day and it kind of almost being a storage system.
Yeah, so the extra device that you would specify as part of the system is called an iBoost, and I think it's about £300 plus VAT. And what that does is it works like an extra immersion, but it takes up any extra solar output that you're not using for anything else, and effectively uses it to heat up your hot water. So what that's doing is it's adding to your main heating system and putting less emphasis on that, because the solar output will raise the temperature of the water in your hot water tank and mean that your probably your gas system does not have to work quite as hard. So it will save both money by using less gas and also carbon, because it's your zero carbon electricity that's displacing grid supplied gas, which is of course at a higher level than electricity.
Thanks, Sandy. How does that compare though with, say, a battery? Because it strikes me that everyone's got a water tank, well, presumably. Maybe I suppose they don't actually.
So not, you're right, not everybody does. Particularly smaller properties use a modern combi boiler, so that only heats the water as it's actually demanded by the system. So in some cases it's not appropriate to be able to use that device because there is no hot water there. But I think what we're saying is that using your excess solar electricity to heat up some of your hot water saves you some gas usage in otherwise heating that hot water. And if you compare that to an immersion would normally use your grid supplied electricity, but could use your solar electricity if you were using the immersion. So I guess it's another way of doing it, but it does depend on whether you've got a hot water tank that's capable of taking two inputs to heat the hot water.
But basically, there's a market failure where if you produce excess electricity, you more or less give that electricity to the grid for free, because you get such a low price for it. That so you are looking for a demand for that electricity within your property versus giving it away for all.
Yeah, I think that's a viewpoint. I think in some ways it's better now than it was 2 years ago, because you got literally nothing for anything that you gave to the grid in those sort of times. And I think in the years of the future, you're going to be able to probably sell your surplus electricity to your neighbour at a price that's below the grid, but higher than you would get as the current export tariff. But at the moment, yeah, it's not ideal, but I think it's better than nothing.
Andy, someone asked about EV charging.
Yep. So IDEA can provide what I would describe as the simple EV chargers, which basically go one way. So they can take your solar electricity to help charge your electric vehicle, and if there's no solar electricity, they can use the grid supply. They supply the single unidirectional ones which can charge your vehicle.
Can I ask, back to the batteries, how big are they? How much space do you have to have for them?
Off the top of my head, because I've been asked this question before, there's something like 45 times 60 centimetres times 15 centimetres. So roughly half a metre square by about 15 centimetres, so 6 inches deep, basically. So not massive, usually wall mounted.
Andy, how long does it take to install a system, roughly?
A typical system is the installation goes in on day one, the installation goes in over days 2 and 3, and then the scaffolding disappears on day 4. Sometimes the gaps can be a bit longer, but probably 2 to 3 days of actual disruption, I would suggest.
Okay.
And if you put a system in, but then you need to repair the roof underneath, is it easy to lift and shift the system?
Well, it's relatively easy to lift and shift, but you've still got to put scaffolding up there. So we would always recommend that you have a look at your roof before the panels are put on and make sure that your roof is in reasonably good order. In most slate roofs, the framing of the solar panels does not go through the tiles. It goes into the rafter space. But I think that's one of the things that they would be asking you as part of the survey process, is to make sure that your roof is fundamentally sound before they start putting things on top of it. Because if you do have to go in and do any repairs to all the tiles afterwards, you've got to take the panels off, which means, you've got to have scaffolding, but I guess you'd have the scaffolding to repair the roof as well. But you're better off doing it before you put the panels up, I would suggest.
But would you have to get the specialists in to take the panels off and put them back on?
You would, yeah, because it's electrically connected.
Right.
Did you mention the warranty period and guarantees and who underwrites them, and also maintenance?
Yeah, so the easiest question, maintenance, they don't need them fundamentally, because once they are put on a tilted roof, they are washed by the rain, and there is normally, in normal UK conditions, there's enough rain to keep them clean and everything like that. Some people suggest that you can buy a maintenance contract. We would say don't, because they don't normally need it, because once they're in position, they don't normally go wrong. The panels guarantee is 10 years for most of the panels that are put up. The inverter has got a 5-year guarantee, but you can also buy an extra 5 years cover as an additional extra. The one thing that might need replacing during the 25-year life is the inverter, and they cost about £500. So, I think in our little spreadsheet, which talks about the economics, it does actually show you replacing the inverter halfway through the solar system's life. The other thing I would say is that as well as guaranteed to against failure for sort of 10 years. The panels are also performance warranted down to 80% at the end of 25 years. So if they're at 4,000 capacity, kilowatt peak capacity in year 1, they would still be at 3,200 by the end of year 25. So they do use a little bit of their effectiveness over that period, but they are still viable and working at the end of that period.
Andy, can I just bring up a couple of points from Marlow Energy Group's side, as it were? One of the things that may be interesting to people is that in our house in Spinfield Lane, we've got 16 solar panels, PV panels, and they're not on the roof. They're actually over the garage. So even if you don't have a roof, which is not particularly accessible or suitable for it, there are other alternatives out there, and ours works very well. And the other thing I wanted to say is there has been a culture over the last 10 years or so of everybody saying, when do I get my money back? It's one of those things that's trotted out every time you talk about PV panels. And I would counter that by asking everybody here, when do they get their money back on their washing machine? When do they get their money back on their conservatory? When do they get their money back on their freezer or garage or anything like that? The simple answer is you're buying something for your benefit, and this actually benefits the planet. So it's a win-win situation. And if you really are desperate to get your money back, if you had two houses, one next to the other, and they're both identical, and one had solar panels on it and the other one didn't, the one that had solar panels would probably cost £4,000 more than the one that didn't. Thank
Interesting. You. No problem. Any more for any more that Kat's not ably answered in the chat box, because I've noticed some of the discussions about carbon footprints.
Just a really silly one, but you said they're maintenance free. What about rodent damage? Squirrels, mice? We've got squirrels over the roof, I hear them. They would like to eat wires.
Right. I've had the same question asked about pigeons who like to roost underneath solar panels. If you think that that's a bit of a risk, then you can spend, I think it's another £200 on a mesh option, which means that they can't get underneath and at the wiring or get underneath the system. So if that's a particular problem, then that's an optional extra I would recommend. But I mean, generally, most people who we speak to don't have a problem with their solar panels, and pigeons roosting is the most popular one I've heard of, and there is a way of preventing that via those meshes.
What about flat roofs, garage flat roofs?
So it is an option. What I would say is that you can't keep the panels directly flat. They have got to be at an angle. So if you've got a flat roof, there's two things to think about. One, it's got to have some sort of framing mechanism to provide a tilt. And the second thing is, has the flat roof got the strength to be able to support both that framing and the weight of the panels? But if that is the case, then I'd just suggest that the cost of the panels would be slightly more, because you've got to pay extra for that bit of framing. But yeah, you can use a flat roof, but you do have to tilt the panels, because panels effectiveness is a function of their orientation and their tilt angle, and whether there's any shade or not. So you do have to make sure that the panels are tilted between 15 and 30 degrees in some way, but there are framing mechanisms to enable that to happen in flat surfaces.
Yeah.
And Andy, how much would does an installation weigh, or a panel weigh, to give an idea of the kind of weight?
Oh, that's a good one. I can't remember that off the top of my head, but we can look that up for you. But they are 1 meter wide and 1.7 meters long is a standard panel. So it's 1 meter by 1.7 meters. I'd like to say 10 kilograms, but I'm not sure that's right or not. So I'd rather not comment on that. But if you go on to particularly JA Solar or
Jinko.
Yeah, Jinko. They're the two biggest manufacturers. Find a standard 340 watt panel. It will tell you the weight of that panel then.
Okay, thanks.
Andy,
it's one I should know, I know.
Andy, while you're talking about the size of panels, another Andy has asked, what's the minimum roof area needed to make it viable to fit the panels?
I think a system which is less than about 6 panels won't really work, because you've got the initial fixed costs of putting the scaffolding and putting the panels up and the inverter. So I think it's got to be more than 6 panels. So 6 panels would be 6 times 1.7. So I'd say that's about 10 meters squared. But what I would also comment on is it depends how much electricity you use as well. If you don't use a lot of electricity, even a small system may still be viable. And what you'll find these days is that IDEA will not specify a huge system for your property if you don't use a huge amount of electricity. It was different in the FITS days where you got paid for every unit of electricity generated, but now they will specify something that is appropriate to your needs, so you get a good proportion of own usage versus the output of the system. So 10 meters squared is probably a good rule, but depends on your consumption as well.
Andy, can I just say, I think we should perhaps go on to 8:30, so we can have a few more questions, and then after an hour, I think probably everyone's had a good evening, as it were.
Let's hope so.
Can I just ask, Kevin has asked, what's the power output in winter versus summer? Do we actually have a chart that shows the different power in winter and summer?
I haven't got one that I could find in seconds, but it's basically a U shape. So you get your minimum output in December, sorry, in January, and you get also in December, but you get your maximum output between June and August. So it is a classic U shape like that. And the only trouble we have in the UK is that people's electricity usage is the U shape going in the other direction, because they use most of their electricity in winter because there's a lot more lighting going on, and they use the least in summer because there's no lighting going on. And that's why it's very, very difficult to use 100% of your output unless you've got something that uses an awful lot of electricity in the summer, like air conditioning, for example. Okay, any more for any more?
Could I just point out to everybody that if they want a copy of the chat, they can download it themselves. If they look at the bottom right of the chat box, there's 3 little dots. And if you just click on those 3 little dots, it will say save the chat, and it will let you save it down to your PC if you want to.
Oh, yep.
Okay.
I mean, if you have a problem with it, we'll be saving it anyway, so we can always send it to you if you have a problem downloading.
Well, if there are no more questions, are there any more questions?
Yeah, I've got a quick question about moss and things growing underneath the panels.
Disappear that way. I'm probably over in Ireland. I've broadcast from Ireland. Really?
Sorry, got somebody else on mute there. Sorry. Could we go on mute unless we're asking questions? Thank you.
From 10 a.m. till 10 p.m. for the next 2 weeks. Well, from up here,
I knew that was.
John, mute all.
Yeah.
Oh, it's Andy who's in control.
Oh, sorry. Can I do that then?
You should be able to. I think it's Anne Bly. If Anne Bly could stop talking.
There you go. I've muted Anne.
Well done.
Try again. Sorry. The question was about what the impact of moss building up underneath the panels?
Well, yes, yeah. I mean, we get quite a bit of moss on our roofs, and what's not clear is when you have panels on top of your roof, what happens underneath? Do you get same amount of moss, less moss, more moss?
I think my gut feel, I don't know the answer to this, but my gut feel would be less, because you're not getting as much direct sunlight onto the roof surface because the sunlight is being absorbed by the panels. So I would expect you'd get less, would be my gut feel. I don't know.
I can answer that, Andy.
Oh, brilliant. Great.
Having had solar panels for 12 years now, occasionally I go up and clean them because they get the occasional bit of bird poo on them. And there's a minute amount of moss which gathers generally on the base of these panels, and I clear that off, but it's millimeters of moss, so I wouldn't worry about it.
Okay, it's interesting.
I was referring to moss underneath the panels.
No, I don't think you get that because, for one thing, you're going to get a bit of heat growing up underneath the panels, and I don't think that's conducive to moss growth. It's not one I've heard of, to be honest, so I don't think it's a serious concern.
Peter's got a question.
Yes, I have. Can you hear me?
Yeah.
Okay. Right. I hear recently that there's a university have come up with a new panel, which is more efficient. Okay. And I'm not sure whether it's in production or not. Is that true? And should we be waiting for the new panel to be produced?
So I think they are producing new panels all of the time. And as I say, even in the 2 years that this scheme's been running, we've gone from 275 watt panels to 340 watt panels. A new technology of all sorts is coming out all of the time. What I'd say is that we'll basically keep up with that technology, but those brand new panels are not commercially available at prices that you'd be able to put a system in at the moment. In 3 years' time might be completely different again, Peter, and that's why the question is always, do you invest now or do you wait 3 years to invest and everything like that? And it's always difficult with this kind of technology because you don't know how it's going to change. One of the popular questions we get asked is, well, if solar panels are now 23% of what they were 12 years ago, are they going to be 23% again in another few years' time? And I think view on that is that the whole system cost will not go down quite as dramatically because the panels are only part of the system cost. The inverters haven't gone down by the same way, and the cost of scaffolding certainly hasn't gone down. I don't believe you're going to get quite as dramatic a difference over the next 10 years as we've had so far, because we're already at a stage where millions, if not billions, of panels are being produced at the moment, and I can't really see it's going to get 5 times bigger than that at the moment. So when's a good time to invest on a new technology?
Okay, thanks, that's great.
No problem.
Could you just explain the payment terms for people?
So it's a 25% deposit. So on a usual system, that's £1,000. Then the second payment, which is 40%, is payable just before the panels go up. And then the final payment is just after the panels have been installed and when the customer is completely happy and signs a satisfaction note. That's when the final balance is due.
Just a quick question, Andy. If someone's got a big house, and there are a few big houses in Marlow, and they've got 6 or 7 bedrooms, how much does 20 or 24 panels cost?
I don't know off the top of my head, but what I would say is that the anchor point of £4,000 for a 4 kilowatt system, which is the 12 panels, if you go above that, the cost per watt installed comes down, and similarly if you go below that size, the cost per watt goes up, because as I mentioned, you've got those certain fixed costs to replace as well. The other thing is, if you go above 4 kilowatts, you have to ask the local DNO, the district network operator, so in our case here it's SSE, if they will allow you to install, because their fear is that you're going to put extra electricity into their grid. It's very unusual on a residential property that permission is turned down, but you do have to consider that if you're putting in a bigger system than 4 kilowatts.
Okay, well, if there are no more questions, is there any more questions? Quick one, no? Right.
I think I just have to ask one question. I mean,
okay.
from what everybody's heard, does that make them more positively considering solar panels? And maybe if you just a bit of nodding heads and some thumbs up would be quite interesting. Yeah, there's some nice enthusiasm there, so that's great to hear. Yeah. Yeah, I'm seeing the icons and thumbs up. That's very good. Thank you, John.
Righto. Well, in conclusion, can I thank first of all Andy and Kat. I think this has been a very good demonstration of what's available out there and what you can achieve. Been very interesting. As I say, it's being recorded, so you can see it again if you want. It will be on the website, and if people say, "Oh, I'd love to see it," point them to our website, and they should be able to download it in a few days' time. Can I thank you all for coming? Much appreciated. Hopefully you found it interesting, and we'll hopefully see a few solar panels go up in Marlow.
Brilliant. Thank you very much, all.
Thanks then. Bye-bye.
Thanks, everyone. Bye.